Alright, welcome to 2D4 video notes. Now we're going to be shooting projectiles not horizontally off of a table or something, but now we're going to be shooting at an angle. The question is, what happens when we shoot a ball 20 meters per second at an angle of 40 degrees above the horizontal? So just to give a picture of what that might look like. So let's first of all, we're going to assume that the ground is flat and that our initial launch conditions then, if we say here that if this is horizontal, we're going to be firing this at 20 degrees above it. So I know this isn't 20 degrees, but it's just my diagram. So here's 20 degrees, and that's how we're going to be shooting it. And the path that it takes, maybe I'll just draw this somewhere else here. The initial launch is going to be 20 degrees above the horizontal. Here, I'll do that again. So that's the initial launch of it. If we think about the path that it will take while it's in the air, it's going to be this parabola again. So it's going to kind of do this shape. So at the very beginning, it has this direction, but it's going to change direction as it goes. So if you recall, the whole key to this unit is that the x really never changes here. The x direction is constant velocity, while the y starts large and then gets shorter. At the top it's 0, and then it has the same velocities but downwards on the way down. So what we need to do is separate this Vx and the Vy. What we're given to begin with is just this velocity here, which is 20 meters per second. No, did I get something wrong? It's 40 degrees. Okay, let me change this number here. Here, if this is 40 degrees, and this is at 20 meters per second here, what we need to do is figure out, well, how quickly is it moving in the x direction? So that would be this side. That would be Vx. And how quickly is it moving up? That would be Vy. So if we look at that, it just looks like a triangle here. So to figure out Vx, we would use cos. So we'd say the cos of 40 degrees is equal to the adjacent over the hypotenuse. So that'd be Vx over 20 meters per second. And so to solve for Vx, we would get Vx is equal to 20 times the cos of 40 degrees. Now, if you're in the habit of, and it's a good habit of putting important things in your notes, I would say that whenever you're given this whenever you have a question like this where you have an initial launch and you want to separate it into the x and the y components, your Vx is going to be equal to whatever the velocity was, like in this case it was 20, multiplied by the cos of the angle, whatever the angle was given. So this is a good one to have in your notes. Similarly, when we do the y direction is going to be using its opposite on this triangle. So that would be the sine of 40 degrees is equal to Vy divided by 20. And so we would get Vy is equal to 20 times the sine of 40 degrees. And can you figure out what that would look like for our general rule? It would be Vy is equal to V times the sine of the angle. Okay, so if I punch those into my calculator for Vx here, I get, maybe I'll write it out somewhere. Vx is equal to 15.32 meters per second, and for Vy I get 12.86 meters per second. All right, so we've got a few questions to answer here. It says, how long is the marble in the air? How far away does the marble land? And things like that. So I'm actually I'm going to add one to this. I'm going to start off with, I'm going to do 3 questions here, or I'll do A and B, C. A, B, C. I'm going to start off with maybe the question, what's the maximum height? So we're going to do like we did before, where we separated into the x and the y directions. The reason why I'm going to do maximum height, because if we think about the shape of this thing, the maximum height is going to be at the top. So I'm bringing this up because depending on the question, you're going to change what is the interval of time that you're interested in here. So in this case, if this is the initial situation, that's the final situation at the top. So when you do maximum height, in this case, the key is that the vertical velocity initially in this question was going to be, whatever we had, I guess it's 12.86. And the final velocity in this case would be the vertically, well, at the very top, it's 0. Okay, for some of the other questions, you might be considering this last point. You might consider the initial to be here and the final to be there. So you got to be careful about what you're thinking about. So why don't we do this one? Why don't we do the maximum height? So let's go over here. So for A, maximum height. And if we think about all our X stuff and our Y stuff like this, I don't think we need to actually think about the X direction yet, because maximum height is a Y thing. So what are we asking for? We're really asking is what is delta Y? Maximum height is delta Y equals question mark. What do we know? We know that Vy initial is equal to 12.86. We know that the final vertical velocity is going to be equal to 0 meters per second. And, well, I guess I didn't formally say what our directions are. I just stopped when thinking about acceleration. I'm going to say that up is positive, and for the X direction to the right is positive, because I said that this was a positive value. So without even making it, formally indicating on my diagram, I was thinking that up is positive. So in this case, when I get over here and I'm talking about acceleration here, I was going to say acceleration is going to be downward, so it's negative at 10 meters per second squared. The one that we're not going to be using is time. So we don't even need that one. So the equation that doesn't use time is, I think it's equation number 5. It's Vf squared is equal to Vi squared plus 2a. In this case, it's going to be delta y. So the final velocity was 0. It was equal to 12.86 squared plus 2 times negative 10. So I can say minus 20 delta y. I'm going to have to subtract that 12.86 squared from both sides. So I'll get negative 12.86 squared divided by negative 20 is equal to delta y. So my negatives are going to cancel each other out. When I get my calculator out for that one, what do I get? I get delta y is equal to 8.26 meters. So that would be the maximum height. So that would be their answer to the first question, which was not on your sheet. Okay, the next question, B, maybe I'll switch to green to keep track of things, is how long is the marble in the air? So when we're asking that question, we're really saying delta t equals question mark. Okay, so again, when I was talking about this discussion about what to use, we could use this as our initial. And in fact, there's a bit of a shortcut we could use. We can consider the numbers that we just had. We could consider all these numbers over here and calculate for how long it takes to get to that maximum height, and then we could double it. Okay, find time from 1 to 2, then double delta t. That would be a method. Or we could actually do something like find this total time from here to over here. So this would be your initial and that would be your final, or find total time. Well, why don't we do the second one here, because that's probably what most people do. So the key here is that we had our Vy initial. Looking at our diagram kind of reminds us that this initial going upwards is going to be the same thing as that final one going downwards, except it's downwards. Okay, so here if our Vyi, I'm running out of space, maybe I'll work over here. So we're going to use we're going to use this method here. I'm going to say Vyi was equal to, what was it, 12.86. So my final will be equal to that negative. My acceleration is negative, and I want to figure out the time. So the one I'm not using is delta y. You probably will be using equation number 4. I think you have to. So the final velocity is equal to the initial velocity plus a delta t. So here we get negative 12.86 is equal to positive 12.86 minus 10 delta t. Subtracting 12.86 from both sides, I get negative 25 something, 25.72, and then divided by negative 10 equals delta t. So I get 2.572. And that would be my answer. Okay, so that would be this one over here. The answer to this question, how long? So the last one is, how far away does the marble land? So what is that asking for, how far away? Well, that is asking for this horizontal direction here. What was the delta x? So I'll do C in red. Now this is the x column. So when I'm thinking in the x column, really I got Vx equals, I got delta x equals, and I got delta t equals. Well, I can use the time that I just calculated, which was 2.572, and Vx, which I found earlier, was 15.32 meters per second. So if v is equal to delta x over delta t, I can solve for that and say delta x is equal to the velocity times the time. So when I multiply those two numbers together, I get 39.4 meters. Okay, so you've got a your turn coming up. I know you're thinking that was lots to do, but really it's a very similar question, so you can take a look at the previous example. How long until it stops rising? So what that is asking is from here to here, delta t equals question mark. How high will it be at this time? So that would be delta y from here to here again. How far away does the ball land? So for part C, you'll be thinking about from here to here, and you'll be solving for delta x. Okay, so I'd like you to hit pause now and give that your turn a try.